All right, so let's look at our pretest. And I'm going to just go ahead and go to preview. And then I'm going to go down and look at our first problem. Here's our first problem. It says, find the slope of a line through these 2 points. How do I do it? Sasha, how do I find the line that goes through these 2 points? It does say here, no calculator permitted for this question. I think that's definitely one possibility, but it doesn't say we can use a calculator. So part of your test to prepare you for the AP test, part of this test is with a calculator and part is without. And it'll just indicate to you as you take the test whether you can or you can't use a calculator. Eleanor, how would I find the equation for that goes through these 2 points? Oh, I just have to find the slope. How do I find the slope between these 2 points? All right, so we can find the change. How do we do that?
So you could take, I guess,
What's the definition of slope? Yeah, we're looking at the change of y over change of x. So slope is defined by rise over run, and the rise, if we're looking at 2 points on a grid, then the rise, Sasha, is the difference between our y values, whatever this y value is, and this y value here. That difference is that the difference would give you that distance. And so we're looking at the difference between our y values. And then to find the run, isn't that the difference between our x values? Oh, actually, this would be 1 and this is 2. So that would be x2 and I think I mixed those up. Okay. So what's our equation? What goes in the numerator? 4 minus 1. What goes in the denominator? -3 minus -8. Okay. So 4 minus 1 gives us 3. And negative and negative is positive. So I have -3 plus 8. 5. So what's the answer? A, B, C, D, or E? A. There you go. So that should be, this is really a secondary math 1 idea, right? It's from secondary math 1. Okay, moving on. Number 2. And again, if you prefer to just work on this on your own without Mr. Hall's help, that you're welcome to do that. And in fact, if I call on you and you're working on your own, just say, Mr. Hall, I'm just working on my own. And that's fine. So here is question number 2. Just throw that one in here and zoom in on it. And looking at the question, it says, write the slope intercept form of the equation of the line that passes through point -2 and -3 that is perpendicular to the line 3x minus 5y equals 1. Emerson, how do I do this one? All right, so I'm going to convert this to slope intercept form. So I have 3x minus 5y equals 1. How would you do that? Okay, so that gives me -5y equals 1 minus 3x. Okay, actually, let me write it. If we're trying to get this in slope intercept, let me rewrite it as -3x plus 1. Okay. Okay, -5 and -5. So that gives me y equals, and we have to remember this, right? A plus b over c equals a over c plus b over c. Does that look right to you? Okay, so that would, what do we do here? Yeah. All right, so I'm trying to find something that's perpendicular to this and goes through this point, right? Emerson, so what do I do? Why is that relevant? Why is perpendicular relevant? Or what does that bring to mind when you think of perpendicular and an equation?
Don't you have to change the slope so it's perpendicular?
Yeah. So do you remember how we changed the slope?
Yeah, would you flip it to the would lead at 5/3 x, but you turn negative.
All right, so we have our new slope is going to be negative 5/3. Is that what you said? Okay, I agree with you. And then we're trying to, so we have the right slope now that's perpendicular. I just need to go through this point. So Emerson, how do I do that? Right now we have y equals negative 5/3 x plus b, right? What am I missing? Yeah, how do I find that? Well, we already have an x and a y, right? What if I plug those x's and y's over here and solve for b? How do you feel about that, Emerson? Does it make sense? Okay, so that gives me negative 3 equals negative 5/3 times negative 2 plus b. Emerson, how do I solve for that?
I guess you would multiply it.
Okay, that gives me 10/3. Does that look right to you? Okay, and then? Okay, and that would give me, that gives me negative 3 minus 10/3 equals b. What's the rule when we subtract fractions? Yeah, this denominator right now is 1, right? Yeah, we're multiplying by 1 in the form of 3/3. That gives us negative 9/3 minus 10/3 equals b, okay? Negative 19/3, all right. So what's our equation then? The equation then is y, the equation that's perpendicular. It's perpendicular to this equation here, and it goes through this point right here. That's going to be what? We have y equals what? Which is right here, right? Okay, cool. Good job. Any questions about this one? Okay, let's look at the next one. Number 3. Number 3 looks like this. And I want to find the domain. What does domain mean? Kata, what does domain mean?
That's all the X values.
Yeah, we're just looking at all the X values that are on the graph. And so let's do this by transformations. Do this by transformations. Do this by transformations. Transformations. All right. Now let's look at the parent. What is the parent function of this mess? The parent function is y equals the square root of x. What does that look like? This is the inverse of what? Yeah, of x squared, and x squared looks like this. So if we have an inverse, it has to be a reflection across y equals x. So we have something that looks like this, right? Okay. Now, this is actually, this blue graph is not a function, right? And besides, whenever we take, if I have x squared equals 25, whenever I take a square root, I need to remember what? Yeah, it can be positive or negative. So in fact, this is two graphs. This is positive, the square root of x, and negative the square root of x. Which the top part or the bottom part? What is it? What's this piece here? What's this piece here? Which is what? That's the square root of x is positive, and the bottom part is the square root of negative, negative the square root of x. So we have two pieces. So we're just looking at the one piece. Now let's consider all of the transformations. Remember the transformations where we have, if I have y equals f of x. Our transformations are a times f of b times x plus c plus d. Remember talking about this? I think it was 1.2. This is an idea you saw in secondary math 2. You also saw this in secondary math 3. Do I have, if I look at this, do I have an a value? Or I should say, what is a? It's not 0. If it was 0, it's all gone. If this is 0, then all of this is gone because I'm multiplying by 0. What is it? What's a? It's 1. In fact, I can rewrite this in this form to be f of x equals what? The square root of, now I don't like how this is written inside of here. It should be written like this. So how do I change that? How do I get the inside to look more like this? Eleanor, do you know? What's that? I just want you to tell me how to rewrite this inside of here so it looks more like this. How about negative x minus 1? Does that look right to you? Is that the same if I distribute back? Negative x plus 1, is that the same? Okay. And then on my d value is what? Minus 2, yeah. So a is what? A is 1, b is louder? Negative 1, yeah, that's my b value right there, negative 1. What's my c value? Isn't this my c value? Negative 1. And then my d value? Yeah. A is your vertical stretch. What's my vertical stretch? Nothing, right? It's just 1. What does B do? What does this B do? It's if it's negative, it's a horizontal flip. So it used to have this here. If I'm doing a horizontal flip, then that's going to be a graph that looks like this. Okay. What does C do? Horizontal shift. In what direction? Opposite of what you expect. So what direction do I go? I go to the right by 1 unit, right? So that should give me this graph here. What does the D do? A vertical shift, all right. In what direction? So what is it? Down to, so 1, 2, I have a graph that looks like this, the purple one. Which is what? What's my domain? What are my X values? Infinity to 1. Yep, right there. Negative infinity to 1. Good with that? If this doesn't make sense, I highly recommend looking back at 1.2. Either watch the class video or watch the videos I have posted there. 1.2 is going to give you a lot of description on that transformation, on those transformations. You only have to learn these once. All of those transformations, they apply to all functions. They are the same. Your A, B, C, and D value, they do the same thing to all functions. Okay, let's move on to number 3. Number 3 looks like this. Oh, I have to find that. It's the same question, but now I have to find the range. So same question, I just have to find the range. So the purple graph is my graph after the transformations. What is the range? Is it? The range is what? The set of all what? The y values. Do we go all the way down to negative infinity? Do we? We just go down to -2. That's the lowest y value is -2. So for the range, let's use a different color. The range is what? -2 included. How do I say it's included? Bracket, okay, comma. Infinity, yep. To infinity. The domain is the set of all x values. The range is the set of all y values. Moving on, unless you guys are, if you're still copying, let me know. I don't have to zoom on so fast. Okay, let's move on to the next one, on to the next one, on to the next one. All right, number 5. I need to identify this as even, odd, or neither. How do I do that? How do I do that? How do I identify something as even, odd, or neither? And here it says not graphically. Because remember, if it's graphically, then if it's graphically, we could put this into our graphing calculator and see whether we have a line of symmetry that is the y-axis. And in that case, this would be odd. Sorry, even. I apologize. It's even. Or if we have rotational symmetry, then around the 180-degree rotational symmetry about the origin, then it is odd. Now, how do we do this algebraically? If it's algebraically, isn't even when f of x equals f of negative x? What kind of transformation is this? It's a horizontal flip. So let's look at something even, like y equals x squared, which looks like this. What happens if I do a horizontal flip? It falls back on itself, so you don't see anything. So do you see how f of x equals f of negative x? What about if it's odd? If it's odd, then negative f of x equals f of negative x. What kind of transformation is this? It's a vertical flip. What about this one? Horizontal flip. So I'm saying it doesn't matter which one you do, you get the same thing. So what if I have a graph that looks like this? This is our y equals x cubed. If I do a horizontal flip or a vertical flip, do I get the same thing? Yeah, so this is odd. So this is how we're going to figure this out algebraically. Which of the two choices, even or odd, would be the easiest to prove? Even, yeah, because I already know what f of x is. I just need to find f of negative x. And if it is, then we know it's even. All right, how do I find f of negative x? How do I, if I know what f of x is, how do I find f of negative x? Josh, what do you think? What does it mean if I have f of 2? What does that mean? Yeah, yep. So we're going to, so I have negative x to the power of 4 plus 1 over negative x cubed minus 2 times negative x. So I just replaced all of the x's with a negative x. Now we have to wrap our heads around, what does this mean? If I have negative x in parentheses to the power of 4, what does that mean? Doesn't that mean negative x times negative x times negative x times negative x? Which is what? What is it? If I have negative x times negative x times negative x times negative x, that's what this is here. It's positive x to the 4. Does that make sense? And negative times a negative is a positive. This negative times a negative is a positive. So together I get what? Okay. Eleanor, does that make sense?
Yeah.
Okay. So that's going to give me, so if I have, that's going to give, so negative, f of negative x gives me x to the power of 4 plus 1. What is this? Negative x in parentheses cubed. What is it? Yeah, and negative x times a negative x times a negative x gives me negative x cubed. So I get a negative x cubed. All right. And then this negative 2 times negative x. Positive 2x. Are these the same? No. So this cannot be even. Now the question is it odd? If it's not odd, then it has to be neither. So how do we, so we just need to take this one more step, right? We just need to, if this equals a negative f of x, then we know that they, a horizontal or a vertical flip are the same. And so it has to be odd. Well, what do we do to find negative f of x? What do we do to the f of x if we're trying to find negative f of x? What do we do to the f of x if we're trying to find negative f of x? Is that to the function or in the function? Louder? To, it's to the function. So let's just multiply all of the function by negative. I have x to the power of 4 plus 1 over x cubed minus 2x. What do I do with this negative here? Where do I distribute it? Do I distribute it through the numerator? Do I distribute it through the denominator, or do I distribute it through both? What do we do with this negative right here? Do I distribute it through the numerator? Do I distribute it through the denominator, or both? To both? All right, so let's try to, so what would that mean if I distributed to both? What does this mean if I have negative 1/2? Does that mean negative 1 over negative 2, which is going to give me a negative divided by a negative is a positive? Does that give me 1/2? No. But I do know that negative 1/2 is the same thing as negative 1 over 2 or 1 over negative 2. Are all these the same? So so what's the answer? You can choose to distribute through the numerator or the denominator, but not both. Agreed? Okay. Which one would I want to distribute it through so that I can get something that might look like this? The denominator. So I'm going to distribute that to the denominator, and that's going to give me that negative f of x equals x to the power of 4 plus 1 over negative x cubed plus 2x, and we get the same thing, which means that f of x has to be what? It's odd. This one is odd. This is odd. Make sense? Any questions?
Could you distribute this negative to both the numerator and denominator? to just one term of each?
If I just, oh, just one, the problem is that that's going to change the value altogether. Imagine if I have something like this. I have 4/10. Now that's the same thing. Let's make it negative. Okay. Isn't this the same thing as negative 2 plus 2 over 5 plus 5? Does that look right to you? Okay. Now you said distributed just to 1. If I distribute it just to 1 here on the top and 1 to the bottom, does that give me the same answer?
No, it doesn't.
No. So you can either distribute to the numerator or the denominator, but not both and not pieces of both. Okay. All right. So yeah, this is not, that would not be allowed. All right. Let's move on. Let's do, what are we on? Number 6. Number 6. This is called a piecewise. Why is it a piecewise? Because it's cut up in pieces. So I'm going to find, it says identify the graph of the given piecewise function. And this question is going to be too big if I try to import all of it. So we're just going to create it ourselves. So the question is, and this is a secondary math 2 idea. And I have to admit that this is probably one of the most difficult concepts for my secondary math 2 students to grasp, because you're looking at the function in pieces. Now I want to graph this. Where would I even start? Well, this is a piecewise, so we start in pieces. Let's try to wrap our heads around what's going on with this. This is a transformation of what? Of this piece of the function here, right? It's in the function, which is horizontal, so we're multiplying, so that's our b value. The b value is negative, so it's going to be a horizontal flip, so I should get this, correct? Okay. Now we're only going to use this piece of the function for what values of x?
I think greater than -4 but less than or equal to 0.
Yeah, so we're going to look at here. If this is -4, I'm going to erase everything that's smaller than -4. Does that look right to you? And then -4 is included, so maybe I'll put a solid point here saying that point is included. And this is also included, so maybe I'll put a point there as well. All right, so we're done with this piece here. So let's wrap our heads around the next piece. How do we do the next piece? What? All right, this is 1/2 x plus 1, which is what? Linear, exponential, quadratic. What is this? It's linear. In fact, it looks suspiciously like our y equals mx plus b. So where do we start? All right, so this is going to be 1, and we're going to start there. It looks to me like when x is 0, it's not included, so I'll make a circle there. Just make a circle there. And then what happens from there? What's my slope? What does that, how do we interpret 1/2? Okay, so I go 1 up, 2 over, 1 up, 2 over, 1 up, 2 over. So I'm going to get something that might more or less look like this. For what values of x? Yeah, so that's going to be, if this is 4 here, then I need to erase this other part here. Does that look more or less accurate to you? We'll say that this is included as well, so I'll put a point there. All right, is that a choice? Cool. Okay, any questions about piecewise? All right, moving on. Number 7. 7 looks like this, and it says, find, what does that mean? The inverse of f of x. Yeah, I have to find the inverse of f of x. So the question is, how do we do an inverse? The question is, how do I do an inverse? What are the steps for finding an inverse? Right, wait, don't get ahead of me. So you're right, I agree with you. We switch the variables. So this y becomes x, and then my x's become y's, all right? Now what? We try to solve for y. So the first step is to switch our variables, and the second thing is to solve for y. The first step is the most difficult because it's not intuitive. The first step, what is the first step? We switched the variables already. What's the next step? By the denominator. We multiply by the denominator. And I would argue that this is the least intuitive, because you're trying to isolate y, you're trying to get y by itself, but yet I'm moving values away from y. So I'm going to multiply by the denominator, which would be my 3y plus 4 to both sides, 3y plus 4. And this goes away, leaving me with this 3y plus 4 times the x equals 2y minus 1. Do you agree that it sounds anti-intuitive to you? We're trying to solve for y, but yet I'm moving y away from this other y. It sounds counterintuitive, right? That we do that. Right, now what? What's the next step? Yeah, let's distribute x. Is that Francisca? Oh, Fernanda. Awesome. Fernanda. So if I distribute that, it gives me 3y times x plus 4x equals 2y minus 1. Now what? Yeah, we're trying to get the y's on one side and the no y's on the other side, right? That's our next step. We try to get all the y's on one side and all the no y's on the other side. So that gives me 3yx minus 2y equals negative 4x minus y minus 1. Does that look right to you? So that was our next step. We're trying to get all the y's on one side and all the no y's on the other side. Actually, that's something important in calculus. So we'll have to do that when we're doing, when we're solving implicit differentiation. We'll have to do this. All right. So what's the next step then? Yeah, let's factor this. How do I factor that? 3x minus y, oh, minus 2, I'm sorry, minus 2, I factored out the y. All right, equals negative 4x minus 1. What's the last step? Yeah, let's divide both sides by this 3x minus 2, this 3x minus 2. This goes away and we're left with y equals negative 4x minus 1 over 3x minus 2. So we have, if you want to, I introduced the problem to you as f of x, so we should probably put this in our, it was f of x, yeah. So let's write this. I had to find the inverse. Well, I found the inverse. The inverse of f of x equals negative 4x minus 1 over 3x minus 2. There you go. The most confusing part is the first part. It seems counterintuitive. You're trying to solve for y and you're moving things, what? Away from y? What? Are you confused?
Yeah. The answer up here is not optional.
All right. What if, my guess is that it's just the order I did it, right? What if do we find, is this an option at all down here? Or, okay, what about this? What if I do this? What if I multiply all of this by -1 over -1? Is that allowed? Can I multiply by -1 over -1? Because this is just 1. You can always multiply by 1. It doesn't change the quantity. Now, if I distribute, what does that give me? 4x plus 1 over -3x plus 2. Is that a choice?
There's a choice that's 4x plus 1 and then 2 minus 3. Is it, or is it, there's one that's negative 4/3 x plus 1/2?
Wait, somebody said something. What was that last one you just said about this one?
That one, but they like switched around.
Because in fact, that's called the commutative property. It's called the commutative property. The commutative property does not apply to all operations, but it does apply to multiplication and it applies to addition. Is it true that 5 plus 3 equals 3 plus 5? Yes or no? Yeah, that's called the commutative property. What about multiplication? What about 5 times 3? Does that equal 3 times 5? Yeah, that's also the commutative property. It doesn't work with division or subtraction though, but it does for addition and multiplication. Right, now, are we satisfied with that? And the only reason I didn't do this on purpose here, it's just that the order that I did it when I solved for it myself, I just did it in a different order. I just put it like here when I distributed and then moved things over here to this other side, I probably subtracted the 4x and put the -4x behind. That was probably what happened. So you still have the same answer. I didn't do that. I didn't do this piece on purpose, even though it turns out to be the same. All right, so let's move on. So what number are we on? Number 8. Are we gonna have time to finish? Have about 45 minutes, about 40? 40 minutes, all right. So this one, I have to simplify. This comes from secondary math 3. The second chapter you did last year was rational functions, the second chapter you did. So we have to figure out how to simplify this rational expression. Nice, okay, so I heard, is that Riley? Riley said keep, change, flip. I love it. When we divide by fractions, here's a tip. Keep, change, flip. Right, so we're going to go ahead and keep, change, flip. So I have x, oops, wrong tool. I have x squared minus 16 over 2x squared plus x times, keep, change, flip, keep, change. And now we're flipping. And there we go. Right, now what? Yeah, in fact, that's what we do with other numbers, right? If I'm trying to find, factoring is exactly what we do. Can you see anything that we can factor in this piece here? This looks suspiciously like a difference of what? A difference of squares. Yeah, if it helps, you could rewrite it like this, x squared plus 0, x minus 16. How do we factor that? Nice, x plus 4 and x minus 4. All right, and then is there anything we can factor here? Okay, so I can factor out an x, so I have x, what's left over? 2x plus 1, right? Can I factor anything here? Actually, that's a difficult one. We have to do that one, we have to do, so 2x squared minus 3x minus 2. Remember how to do this? Remember how to do this? All right, so I have 2x and x, all right? And we're trying to think of some combination. So the outer numbers plus the product of the inner numbers gives us -3, right? What is it? -3 and +1. So that would give me -3 in the inside and 2 on the outside. So wouldn't that give me -1, not -3? So that doesn't look like the right combination. So what do we do? What's another choice? Oh, aren't we multiply? Don't we have to multiply something to be -2 and not -3? Okay, let's do -2 and +1. So the inside would be -2 and the outside would be 2, and that gives me 0. Okay, let's try that. +1 and -2. Inside I get 1, outside I get -4. Does that give me my -3? Yes, no, maybe so? Louder? Yeah, so there we go. We have, that would give us then 2x + 1 and x - 2. Okay, and then we have x + 4. Where do we go from here? Where do we go from here? What can I cross simplify? Nice, cross simplify. What can I cross simplify? Okay, x + 4 divided by x + 4. Okay, that's just one. 2x over 2x, that's also one. So what are we left with? We're left with x - 4, x - 2 over x, right? Yes, no, maybe so. But there's certain values for x we're not allowed to have. Now I know it can't be 0, but that's already implied with this problem. So I don't need to say x can't be 0 because it's already implied that x can't be 0 because that gives me an undefined function. So what am I missing here that this function says about x? Okay, I agree with you. Crossed out this, so that didn't appear in our answer. So x can't be -4. I agree with you. What else? What is it? It's also -1/2. We can't be -1/2. Where did you get -1/2? Yeah, we're trying to figure out what this has to be 0. So we rewrite that as 2x + 1 = 0. We solve for that. It gives us 2x = -1, and then x = -1/2. That's another value that x cannot be, that shows up in the original problem, but not in our answer. So we have to say that x can't be -4 and x can't be -1/2. Are we good with this? Yes, no, maybe so? Okay, moving on. Are we going to be able to finish? Are we going to be able to finish? All right, we are on number 9. This is called a complex fraction. It's a complex fraction because I have fractions inside of fractions. Now the question is, do you know how to simplify a complex fraction? How do we simplify that? Josh, any ideas? Where's Dylan? One's not here. Miguel, any ideas? You're still thinking about it? Okay. Yeah, if we can get one fraction divided by a fraction, then we can do keep, change, flip, right? So let's make sure we have a fraction and a fraction. So how would I get a common denominator? I have to multiply this side by what? Yeah. And I'd multiply by 1 in the form of what over here? Yeah. So in my numerator, I'm going to distribute, if this is okay, I'm going to distribute at the same time. So that gives me x squared plus 2x. I'm getting a little sloppy there. Let me go back. X squared plus 2x. And then we have to distribute this mess up here. So that's going to give me, keep me honest, x squared plus x minus 2x minus 2. And I don't want to distribute the other part because it's already factored. And I'm hoping that later I can find something to eliminate later. This is already all the way factored. Was this factored up here? Not all the way because we were adding. So we have to combine everything before we can factor. Can I factor anything down here? Right, so I have 4x minus 3 over what? Okay. Which means if I do keep, change, flip, what disappears? Yeah, if I do keep, change, flip, this disappears and we're left with x squared plus 2x plus x squared. I don't want to rewrite it all. Can I eliminate anything in the numerator? The top numerator, this one here. Yeah, I can get rid of those. And then that gives me what? 2x squared plus x minus 2. Does that look right? Minus 2, does that look right? All over what? 4x minus 3. Is that a choice? Okay, there you go. Moving on. Mr. Hall, you go too fast. I actually don't know. I don't know if I'm going too fast because nobody's telling me. You have to advocate for yourself. You are the best advocate for yourself because you know more about yourself than anybody else. What is the amplitude? What does the amplitude mean? Isn't that the height of your wave? So the height of the wave sounds suspiciously like a vertical stretch. Yeah, but we actually just by inspection, we should know the answer to this just by looking. What is the amplitude or my vertical stretch? 1/2. Isn't that my A value? The A value is 1/2. So your A value is 1/2. There you go. Riley, you good with that? Yeah. Okay, let's do the next one. Moving on. Next one says, what is the period? Well, the period is where we're talking, it's periodic. So we have, a wintertime, a springtime, a summertime, a fall, a wintertime. We're looking for a full cycle. We're looking for a period. Now, normally, so if we're going to change the period, that seems to me like a what? A horizontal stretch. It's some type of horizontal stretch. Now, in order to understand what the period is, we need to understand what the period is before we do any transformations. What, for cosine, without any transformation, what is a period? It's just 2 pi, right? I think you're, Fernando, you're ahead of me. I wasn't actually going to say that. I was trying to avoid saying that because I don't want to make it an equation. I just want you to think of it logically. So what do we agree that with cosine, our cosine is our x value. And for us, we always start at the initial side. For us to do a full rotation, we're talking about 2 pi in radians. Now remember, so normally without any transformations, it's 2 pi. Now this is going to be some type of horizontal stretch, which is what? My A, B, C, or D value? It's my B value. What is my B value? It's pi halves. So I'm going to stretch this period by a factor of pi halves. Oh, wait a minute, we have parentheses. We always have that funny business when we have parentheses, which is, yeah, 2 pi over pi. How about that? Or sorry, 2 over pi, right? Yes? Okay, or which would give us what? 4, so it's 4. It sounds like Fernanda has the equation memorized. The equation this works for all sine and cosine, not tangent. Tangent, the equation would be different. But Fernanda, you said that the period was what? What's the equation for it? 2 pi. Yeah, that's our equation for period. If you wanted to memorize that, you can. What if you're given the period, but you're trying to figure out B? Well, we'd multiply B to both sides and then divide by P to both sides. Doesn't that give us B equals 2 pi over P? If we're given the period and we're trying to find B, does that make sense or not? Okay. So both of those are, yeah, or you could think of it logically. This is the period, normally a period is 2 pi, and we're stretching by a factor of 2 pi. Well, pi halves. Well, no, we're not, because we have that funny business in parentheses. So the multiplier is 2 over pi, which is what we have here. So either way, we'll get the right answer. I just like this way, Fernando. I like this way because it ties it into what we already have learned about transformations. It's just that funny business. But yeah, having it memorized too is fine. Either way. Right, so it's 4. Is that what we decided? Did I lose my class? Okay. Yes, it's 4, or yes, I lost my class. Okay, or both. Okay, so next one says that what is the domain? The domain is the set of all what? X's. What X values show up for cosine? Yeah, all of them. Every real number shows up for cosine, because remember, it's periodic. It just goes up and down, up and down, up and down forever and ever and ever. So this is going to be from negative infinity to infinity. That's my domain, the set of all X values. The next one is the set of the range, which is the set of all what? Y values. We have to think of a transformation for this one. We have to think of a transformation for this one. Partly. It is partly. So so Riley said, is it based upon the amplitude? And that's partly true. Now let's consider if we just have y equals cosine of x, we have a function that oscillates back and forth across the x-axis from what are my max and mins? -1 and 1. Yep, we're going from -1 to 1. But now there's been some transformations. One thing was that the amplitude is 1/2. That's what Riley said. So if our amplitude is 1/2, then now we suddenly have a graph that looks like this, right? So is our range from -1/2 to 1/2? Why not? There's a vertical shift that happens as well. What does that vertical shift do? Yeah, I move all of this down one, so we are oscillating across what horizontal line? -1. We're oscillating across this line, the -1. So the graph should look something like this. Agreed? Then what is my range? -3/2 to -1/2. Does that make sense, or are you confused? Does that make sense why the new range is from -3/2 to -1/2? Do you want me to explain that again? We're good? Doesn't feel, you guys know you're taking a test next time, right? How come you're not more excited? You got to be excited. You get an opportunity to show your understanding of the math we've covered so far. So this is an exciting moment. Sorry, what's that? Identify the graph of the following function. What does 1/2 to the power of x do? What kind of graph would we have? What kind of exponential? Is this exponential decay or an exponential growth? Why is it an exponential decay? Yeah. So the important part, I actually like this image. I really like this I really like this image. If my multiplier, what if my multiplier is 1? So I have y equals 1 to the power of x. What does that look like? If I plug in 0, what do I get? If I plug in 0, what do I get? I get 1. What if I plug in 1? What if I plug in 2? What if I plug in 2? 1. What if I plug in 3? So I always get 1. Now, if my multiplier is a number greater than 1, then this is an exponential growth. If it's a number less than 1, it's an exponential decay. Actually, it should look something like, well, we're going to start at 1. Actually, here's the problem. I have 1/2 times -1. What is the negative exponent rule? Yeah, so what I get is 2 over 1, which is 2, right? So right? So that's going to give me something like this. Should look something like this. Is there a graph that looks like that? Okay. That's 14. How many more questions do we have? Yeah, are we going to make it? Or do you have confidence? Oh, let's see. All right, let's see. So the next one says, use our function here as a baseline. What transformations occur with this function here? How many transformations do you see? How many? 2. What are those 2 transformations? Louder? Yeah, down 3. This is my my D value. D as in dog is my D value. This is it's a vertical shift down by 3 units. So that would be a shift to down by 3 units right there. And then this negative here, is that to the function or in the function? 2 is vertical or horizontal? Vertical. So that's a vertical reflection. Yep. Questions about the transformations? Okay. So you still nervous we're not going to make it? I have faith in you, Mr. Hall. I think you can do it. Well, hopefully. Let's see. Okay, let's look at this one. Number 16. Any suggestions of where to start with 16? Yeah, so we have a law that says if I have log base C of A plus log base C of B. We can rewrite this as log base C of A times B. So we can rewrite this as log base 2 of x plus 7 times x plus 8, and that equals 1. All right, now what? Distribute. Well, we could, it's just, it might end up being a big mess. We may have to do that, but not yet. That's not going to be helpful yet. How do I get rid? Remember what logs are. What's the definition of a logarithm? What is the definition of a logarithm? It's the inverse of an exponential. Because they are inverses, they undo each other. Which means if I take this value and plug it in here, or I take this value and plug it into here, they do what? Undo each other. So if I have a to the power of log base a of x, this has to be what? It has to be x. Now I'll do the other way. I'm going to take this value here and plug it into here. So I have a to the power of log base a of x, which has to be what? Louder? Oh, did I do the same thing again? Okay, I'll try that again. The other one, I have log base a of a to the x. I've taken this value here and plugged it into here. So that has to be what? X. Okay. Just like if I have the square root of x squared, this has to be x. Or if I have x squared and inside we have the square root, this has to be x. They're inverses. They undo each other. So let's go back here. So thinking of this logically, how can I implement this concept right here to our function here? Yeah, let's do a base 2 to both sides. These are inverses, just like this. We're left with the exponent. So that would, oh, sorry, this way, we're left with this x here. So these are inverses, and we're left with x plus 7 times x plus 8 equals what? What's 2 to the power of 1? 2. Okay, now what? Yeah, otherwise we have to think of what are my x's so that we get 2 over here. So we get 2 over here. It's so much easier to say, what are my x's? So I get 0 over here because the other side's 0. That's so much easier. So let's do that. Let's distribute. It gives me x squared plus 8x, distribute here and here. That's plus 7x plus 56 equals 2. And then it gives us x squared plus 15x plus 56 minus 2 equals 0. Is that okay? Is everybody comfortable with what I did? Or do you feel like I cheated somehow? Are you okay with what I did? Okay. Why do I want 0 over here? Because when I factor, it's so much easier to figure out what are my factors, so I have 0 because the other side is 0. That's why. All right, so what do I do now? Okay, that gives me x squared plus 15x plus 54 equals 0. All right. And then to get what? Isn't it a lot easier now to figure out what are these x's so I get a 0 equals 0? That's so much easier. I don't know if I could figure out. It would take me a long time to figure out what are these to give me 2. But this is a lot easier. Okay, what are my x's? And -9. Now, honestly, up until yesterday, these were the answers. Until I had some student, Thomas, wrote to me and said, Mr. Hall, one of these solutions doesn't work. Which of these doesn't work? This is called extraneous solutions. Do you remember that from last year? Extraneous solutions. It's possible to find a solution that's not a solution. So it's always a good idea to go back and check. They are called extraneous solutions. One of these doesn't work. Which one? Why does -9 not work? Yeah, log base 2 of -2 and plus log base 2 of -1. Remember what a log function looks like, right? This is our y equals log base a of x, right? What does it mean if x is negative? That's -1, that's -2, that's -3. Where's the graph over here? There's no graph, which means x cannot be what? X cannot be negative. What if I plug in -6? Is that okay? Can I plug in -6 here? Does that violate any rules of logarithms? Yes, no, maybe so. Can I plug in a -6? Yeah, that doesn't give me a negative number, so that one's allowed. The -9 is not allowed. So I'm going to conclude, thanks to Thomas, because he pointed that out, that we have what is called an extraneous solution. This cannot be a solution. Even though we found it to be a solution, it can't be. So there's just one solution, and it's -9. Good with that? Question? Just -6. You can, I said select all that apply. Yeah, because I think you're going to select -9. In fact, I did. I did. Mr. Hall messed up. What? Mr. Hall's not perfect? What? What?
Wait, so does that mean that the answers in the test will still have it if we submit that as the answer?
I've changed it. I changed it last night. Yeah, Thomas wrote to me and said, Mr. Hall, really? And it's like, oh, and it's like, because you should, at the end, you really should check your answers. You should and see if it's a solution. Otherwise, you could end up having an extraneous solution. So always check your answers. So that's just a good reminder for me that I need to do that. Yeah, the answer is only -6. If you mark -9, you'll get it wrong. Okay, so let's move on. Next one. Oh, we have what, 10 more minutes, 11? Getting nervous, getting nervous. All right, so it says here, the number of guppies in Susan's aquarium doubles every day. There are 4 guppies initially. Write the number of guppies as a function of time. How do we write, what kind of function is this? Is this linear, exponential, quadratic? What is this? What tells you it's exponential? That's a secondary math 1 question. What tells you that this is exponential? This is a secondary math 1 question. It doubles, yep. Because it doubles, that makes it exponential. So if you recall, this was the equation for quadratics. I'm sorry, for exponentials. I have y equals f of 0 times our ratio to the power of, I don't know, of t, right? And I can prove that because if I have at time 0, if I have, how many guppies do I have at time 0? 4, right? And then it doubles. So one more day later, I have how many? 8, and then 16, and then 32. Let's write this out. This is 4, and this is 4 times 2, and this is 4 times 2 times 2, and this is 4 times 2 times 2 times 2. So we have 4 times 2. What's our rule when we multiply multiple numbers? Isn't it an exponent? There we go. Does that make sense why this is our equation? Okay. I have a couple more questions. Oh, I'm nervous. I'm getting nervous. Okay, let's look at the next one. It says, how many guppies were present after 1 week? How do we find out? Yeah, we plug in 7 here. What do we get when we plug in 7? 4 times 2 to the power 7 is louder. 512 right here. Okay. Okay. 2 more. Getting nervous. All right. Next one. When will there be 2,000 guppies? How do I calculate when I'm going to have 2,000 guppies? Yeah, so I have 2,000 equals, and we still have our equation. How do I solve for t? Okay, we're going to divide by 4 to both sides. That gives me what, 500? 500 equals 2 to the power of t, all right? Yeah, log base 2. Log base 2, that's one of our inverses that allows us. What was that inverse? If I have log base 2 of 2, what was that inverse? What was that inverse? Log base 2 of 2. Wasn't that these are so important. I mean, I hope I hope these made sense to you when we went over these. The definition of a logarithm is it's an inverse of an exponential. So we have this. Whenever I have log base a of a to the power of x, then the answer is just x. So this becomes easier to solve then for the amount of guppies. So this part here becomes what? What is this over here? It's just t. So I have t over here. And then we have to, can I use a calculator on this one? Does it say calculator or no calculator? It says what? Oh, you can? Right. What calculator are you going to use on the test? Or is there a calculator option? Am I giving you a calculator option on the test? I don't know if I was, maybe not. You could use these calculators over here. Does anybody have a TI-84? If you have a TI-84, please take it out. Otherwise, come and grab a calculator. I know we don't have a lot of time left, but I want to make sure you know how to use these calculators. With a TI-84, I want you to push alpha window. Alpha is the button on the left-hand side, top left, and then Windows at the very, very top next to the screen. For if you have a TI-84, push alpha window. Does it give you a choice for logarithms? Okay, then do log base 2. If you are using a TI Inspire, you can use I will allow you to use these calculators during the AP test. So just come and check one out for the day of the test. So we need to make sure that we understand how to use these. Now there should be a button on the right-hand side. Is there a button that has a bunch of little boxes and stuff on the right-hand side in the middle? No? Right here. It's next to the book. It's next to a picture of a book. If you push that, is there a logarithm choice? No? Wait.
Yes. Just hard to understand. Yes.
Which one is it?
It's this
Oh, yeah. Yeah, it's the middle top. The middle top.
right next to the E.
Right next to the E. You see it? There's another way to do it, but I would have to look at this calculator. Oh, on the left-hand side. On the left-hand side, you have log in yellow. Do you see that? You see log in yellow? Yes or no?
Yeah.
Okay, so you could push the control and then the log in yellow, and that should be another choice. Want to make sure everybody knows how to do this. Emerson, can you find it?
Yeah.
Okay, so what is log base 2 of 500?
8.96.
Okay, 8.9. I'm going to round up to the next full day, so 9. Is 9 a choice?
Yes.
Okay. Did everybody find this? Does anybody need help with their TI-84? TI-84, push alpha,
84 plus.
that's fine. Push alpha, alpha is on the left top side. Mine's green, I don't know what color yours is. And then push window up at the top by the screen. Now, number 5 should be a choice for log or any log. Does it give you a choice? What does it say when you do that?
It just- it's something that I'll-
Okay. The other choices you can go down to categories. Right there. Also blue, category would be blue and that 0. So let's clear this, let's get out. And then go to category, so second, in category. And then let's see if we can scroll down to see something that has, yes, you have to all the way down to health, right? Log. I think that's just log base 10. So you'll have to use the change of base formula. Do you guys remember what the change of base formula is? Do you remember the change of base formula for those of you who cannot use log any base? What is log base 2 of 500 in the law or the change of base formula? Yep, over log of 2. Yep. Or you can do ln if you prefer. It doesn't matter. Let's make sure we get the same answer. What is the answer we get? 8.96. Are you getting the right answer using the change of base formula?
Yeah.
Okay, just remember that subscript. What's your name? Yeah, Ellie. Just remember the subscript. So log base 2, that's going to be the denominator. Okay. Okay, so let's go back here. And so the answer was what for this one? 9. Okay, we have one more. All right, so it says here, I want to graph this. This is actually an important concept. So in your calculator, if you're using a TI Inspire, you're going to have to go to the graph button. With the TI-84s, you're going to have to go to the top where it says y equals. Y equals. Do you see y equals? Now, does everybody see for those of you using the TI Inspires, do you see how to graph? You see that? Okay, you're going to type in. This is really important. Please pay attention. I want my solutions to be x-intercepts. Well, for an x-intercept, y has to be what? 0. Let's make 0 y. If y is the 0, then the solutions are the x-intercepts. So let's graph it and see if you can identify an x-intercept. For the TI-84, you're going to have to use second trace and select 0. And then it'll ask you to be on the left side and the right side. I think I'll probably have to explain this part again. It steps you through, find a right side and the left side. It should just give you an option at the top. So I push tab. Push tab and it opens up a window for you to type something. Oh, you wanted to make y 0.
Yeah.
It's not.
Okay.
Oh, well, the fact is that the 0 is now y. Change it to y. Yep. This is not graph. We'll have to look at this again. So. We'll have to look at this again before the test. So just remind me before the test to go over how to find the next intercept. That is something that you do need to know though.